All right, here's today's lesson. Today, instead of having two variables and finding an x and y coordinate, we're going to have three variables, and we're going to find an x, a y, and a z. So we're dealing with three dimensions. It's just not on a sheet of paper. Our third axis, our z-axis, is going to be coming off of our paper, giving us three dimensions. If you felt comfortable with our elimination from last class, we're going to be okay. If not, hopefully as we go through this, it'll make a little more sense. Take notes as we're doing this. Do the problems with me. And once I tell you to start working, or once we get an idea, pause the video so you don't just copy what I have and you can see what's going on. All right, so again, our goal for this class is to find an x and y and a z using three variables. Our first problem on the board, and again, pause it whenever you need to. We're going to work backwards. This first two problems are going to be ideas that we use in almost every single problem. All right, so we're going to get to a point that looks like this, and we're going to be able to do this. All right, so I'm looking for that x, y, and a z. From the beginning, I have a z to equal 2. And that's just what we have. Knowing that z equals 2, I can take that value of 2 and plug it into the previous equation. Replace z to be 2. Do my math. And I get my y value to be -1. So now I'm 2/3 of the way through, just from what we're given. Now that I have those two, I have a z value and a y value. I can plug them into the original top one, x minus 2 times my y, plus 3 times my z equals 9. Do all my basic algebra. And these three-dimensional equations would intersect at the point 1, -1, 2, the x, y, and the z. All right, so we're given a z. We use z to find y. Once we get y, we use y and z to find x. All right, that's the idea we're going to do at the end of most of the problems. All right, so do number 2. Do the same idea. So pause it, do the math, and replay the video and see if you agree with what I have. All right, plug in a 3, y plus 9 equals 6. I get y to equal a -3. We'll plug it into the top one. 2x minus my -3 plus 5 times 3 equals 22. 2x plus 3 plus 15. 2x plus 18 equals 22. 2x equals 4. And the third part of my ordered pair is going to be 2. So given 1, we're going to plug into a 2-variable equation to find another one. Then we're going to take those 2 and plug it into a 3-variable equation to find the third. Make sure we write all our answers as that 3-variable coordinate. That tells me you know what we're looking for. All right, now, and how we're going to get there. I'm going to give you this equation. This systems of equations, 3 of them. All right. What we are going to do is we are going to use elimination 3 times. Using elimination 3 times is going to allow us to solve and find our x, our y, and our z. All right, so when you do your homework, you do a test or quiz, whatever we have, you do not have to do it one specific way. Whatever way works for you is going to be fine with me. So looking at this problem, what we want to do is we want to get rid of one of our variables using elimination. So I'm going to look at the x's, the y's, and the z's. I'm going to decide which variable doing elimination twice is probably going to be the easiest one to get rid of. So looking at this, what I'm going to choose is I'm going to get rid of the x's. Because if I group these two equations together, my x is going to cancel pretty easily. If I group these two together, with a little bit of math, I can make my x's again disappear. So we're going to do elimination twice using my x's. So I'm going to take my first two equations. I'm going to eliminate and get a two-variable equation, y plus 3z equals 5. That's a good thing. All right, I got rid of my x's. Now doing the bottom two to get rid of the x's again, I'm going to multiply this one by 2 so I can cancel. Negative 2x plus 6y equals a negative 8. And then my bottom equation stays the same. So to work on these two equations, to make my x's disappear, I'm going to multiply the top by 2 like we did last class. Now, I get y plus 5z equals 9. I eliminated twice. Right now I have these two equations. When I write them next to each other like this on top of each other, I'm going to eliminate again. And my choice to get rid of is I'm going to get rid of the y's. So I'm going to multiply the bottom by a negative 1. I go through my steps like last night. I'm going to get a z value of 2. And again, as we do this, pause it, do the math, go through it. So going back to the top, I looked at the first two and I eliminated the x's, which is here. I did the bottom two, I eliminated the x's and got me to here. Those two equations, I eliminated the y's, and I found that my z equals 2. Now we're going to go back like the first problems that we did. In one of these two equations highlighted in yellow, we're going to plug z to equal 2, and we're going to find y. So I'm going to pick the top one because my numbers are smaller, but it doesn't matter which one you pick. So I'm going to go y plus 3 times 2 equals 5. Y plus 6 equals 5. Y equals a negative 1. Now I have x's or y's and z's. Once I get y's and z's, I'm going to come over here and pick one of these three original ones to find x. Doesn't matter which one you pick, but for me to make my math as easy as I can, I'm going to plug y and only y into that middle one. And I get x equal 1. If you pick the first one, the top equation in green, plugged in negative 1 to y, 2 into z, you'd still get 1 as an answer for x. If you did the bottom one, it's going to come out to be the same. And that's the basics for today. All right, so going back to the top, just to explain it again, I picked two equations, the top two and the bottom two, to cancel out the x's, giving me these two equations. Once I got those two equations, I eliminated the y, was able to find z. I used z to find y. I used y to find x, and that's our problem. So if I were to graph these three equations in three-dimensional space, they would intersect each other at the point 1, negative 1, 2. All right, now that we have that, I'm going to do some erasing. And we're going to show you another idea which we're going to need for today's homework. All right, you can always rewind and go back to what we had. All right, so also looking at this problem doesn't have a z value. So what I can do is I can take these two equations, take the top one and the bottom one, and do my math, which I'm not going to show because you can do this, to eliminate my z's. Then I'm going to have some number x plus some number y equals a number. All right, just go through the process, eliminate the z's. If I do that, I can use this x and y equation and that x and y equation, like we did last night for homework, to eliminate and find either x or y. And then you can work your way back. So if you're missing a variable like number 3 is on the second equation, I can take the first and the third one and get rid of that variable that's missing, get rid of the z's, and use this answer and that to finish the problem, which would put us at this point of our problem. All right, it'll be helpful. I think there's 2 problems that you can easily do that on your homework. All right, number 4. All right, again from the beginning. Pause it, write the problem down, unpause it so you can get back to where I'm talking. We need to pick a variable to get rid of. Looking at this problem, if I had to get rid of a variable, I would probably not get rid of the x's. That seems like too much work, but the y's and z's being 1s and negative 1s are going to be good. So we're going to cancel the z's. All right, so to cancel the z's, all right, I'm going to use the first and the last one, because that's going to be a good way to get my z's to cancel. And then I'm also going to cancel the second and the third one, because if I have positive z and negative z, that's what I need to happen. So I'm going to do elimination on the first two to get rid of the z's, the top and the bottom. So x plus y plus z equals 6. 3x plus y minus z equals 2. 4x plus 2y equals 8. There's going to be one of my equations. All right, now to do the bottom two, do your elimination again. I eliminate, oh, my y's cancel, my z's cancel. So I get the equation 5x equals 5, which is good because now I know that one of my values of my coordinate is going to be an x value of 1. So that was a good one because something good happened for me. Now, knowing that x equals 1, I can go into that equation I made to find my y value. Now I have a y value of 2. Having x and y, I'm going to go back to the way top. No, that's not x and y, that's x and z. X and y, I'm going to go into one of these to find z, and I'm going to go into the top one. Doesn't matter which one you pick. And my solution is going to be in the coordinate 1, 2, and 3. So from the top, decide which variable you want to get rid of. I chose the z, so I picked the top and the bottom equation, and then the bottom two and canceled out the z's. The top and the bottom gave me this equation to work with. The bottom two gave me my x to be 1, which helped me find y, which helped me find z. All right, when we finish this, if you need help, talk to the people around you. Work together on the homework. Help each other out. All right, one more problem looks like this. And then we got one more to wrap it up. All right, here's our equation. Go ahead and write it down. What we need to decide is what variable we want to get rid of. You can pick any variable, X, Y, or Z. What I'm going to do is try to pick one that's going to make it my math as easy as I can. All right, my thought, I don't want to do 5, 2, and I don't want to do 2, 4. I'm going to do Y's. I'm going to cancel Y. So I'm going to pick these two first. 2x plus y minus 2z equals 7. X minus 2y minus 5z equals negative 1. All right, to get rid of my y's, I'm going to multiply the top equation by 2. 4x plus y minus 2z, oh, I just didn't multiply everything. Multiply everything by 2. Leave the bottom one the same. 5x minus 9z equals 13. All right, I got rid of the y's. Now I'm going to go back over here and look again. All right, what other two do I want to use? Let's use the top and the bottom. 2x plus y minus 2z equals 7. 4x plus y minus z equals 1. And again, it doesn't matter which ones you choose. Whatever you think is going to work the best. All right, so if I want to get rid of the y's, let's multiply the top one by a negative 1. If you did the bottom one, you'll still get there. Oh, there we go. Thank God I found this mistake. That should be a plus sign. Plus z equals 1. All right. 2x plus 3z equals 8. And I'm messing up all my signs. All right, so when I distribute, this should be a negative 7. From the beginning, this should have been a negative 1. So let's make that negative 8. The biggest problem we're going to have on these is just what I did right there, making a careless mistake. So I wrote this problem down wrong. This should have been a plus and this should have been a minus. When I distributed the negative 1, that should be a negative. All right, so make sure you don't make careless mistakes. All right, 2x plus 3z equals a negative 8. Those are my two equations like last night's homework. So now I need to solve, and I'm going to solve and cancel out the z's. So I'm going to multiply the bottom by 3. All right, so I get 5x minus 9z equals 13. 6x plus 9z equals a negative 24. 11x equals negative 11. I get x to be negative 1. All right, hopefully we're doing this ahead of me, not just copying. All right, I'm most of the way there. Now, since x equals negative 1, I'm going to go into one of these two equations, and I think the bottom one's going to be easier. So I'm going to go 2 times negative 1 plus 3z equals negative 8. I'm going to solve. And I get my z to equal a negative 2. Lastly, I'm gonna go into one of these again, and I'm gonna pick the bottom one just because. 4 times -1, which is my x value, plus y, plus my z value of -2 equals a -1. And I get a y value of 5. Every one of these problems, the only option we have to check to make sure we're right is by putting x into all three, y into all three, and z into all three, and make sure that they equal each other. Take that time, check your answers. All right, so from the top, I chose to get rid of the y, so I picked the top two in blue and pink, then the top and the bottom in red and in orange, and I eliminated. Once I got these two equations, I eliminated again and found x to be -1. Then I substituted -1 into x and found z. Then I substituted both of those to find y, just like the first two problems. All right, one last problem, kind of a word problem now. All right, there's a quadratic equation, y equals ax squared plus bx plus c, whose graph passes through the points -1, 3, 1, 1, and 2, 6. We want to find the equation ax squared plus bx plus c. So we're trying to find an a value, a b value, and a c value, given these 3 points. All right, so looking at this, my thought is y equals ax squared plus bx plus c. I need to find a and b and c, and I'm given a whole bunch, or 3, x and y values. So what we're going to do is I'm going to take them one by one. I'm going to take this ordered pair, x, y, -1, 3, and I'm going to substitute them into the x's. I put 3 into y, -1 into x. I'm going to clean that up. -1 squared is 1 times a is a. B times -1 is minus b plus c. All right, there's one of my equations. I'm going to do the same thing again. This time I'm going to put 1 into y and 1 into x. And I'm going to get 1 equals 1 squared times a is a plus b plus c. Then lastly, I'm going to take these 2 points again, plug them into x and y. And I get these 3 equations. Now, this is our system. We're going to solve it like we've done the last 3 problems. So, you can solve this any way you want. You can get rid of the a's, the b's, or the c's. Doesn't matter. But what I'm going to do, just because I can only do one way on the board, I can't do all of them. You don't want to watch all of them. I'm going to get rid of the c's. So to get rid of the c's, I'm going to choose the first 2, and I'm going to choose the last 2, and I'm going to get rid of the c's. All right, so the first 2. Eliminate the c's. Do your math. And I think this works out good for me because my a's cancel. my c's cancel, giving me a b that equals -1. That doesn't do me any good right now because I don't have anywhere I can substitute that in to find what else I need. All right, so let's do the bottom two equations. I'm going to multiply this one by -1 again, like I did here. You get 5 equals 3a plus b. All right, we just said my b is -1. So I'm going to solve and get my a to be 2. I still need c, so I'm going to go into this middle equation. 1 equals my a, which is 2, my b, which is -1, plus c. And I get my c to equal 0. So the only new idea for this is we're going to take this equation, substitute the x and the y into each of it 3 times, giving us this highlighted yellow that we solve. My final answer, I'm going to write this equation. Y equals my a times x squared, which is 2x squared, my -1 times x minus x plus 0. I'm not going to write the 1, I'm not going to write the 0. And the quadratic equation that has these points is y equals 2x squared minus x. If I erased the problem and just gave you this, you would tell me that coordinate 2, -1, 0. But since they want the quadratic equation, we plug back those a values, the b value, and the c value into this equation, giving us what we really want. Individually, no step is that bad, but when there's this many steps, it's very, very easy to make a mistake. When your numbers start getting out of control, when you get fractions that don't make sense, or you're getting really, really big numbers, you may want to go back and try it again and find your mistake. If you can't find your mistake and it's just not working out, cross out everything you've done and do it again, and you might be able to correct your mistake. All right, for your homework, you have the problems in WebAssign. If you have questions, send me a message to the program. I'll do my best to answer. So use this time now. Hopefully you have about half hour left or so. Work with somebody, talk to somebody. Make sure you have a good idea so when we come in on Tuesday of next week, we have a general idea of what's going on. Have a great day.